Hi everybody. In this lesson we're talking about lesson number 11, London forces. Now what are London forces? London forces are weak forces that hold molecules together. So there's two types of forces we're going to discuss here. We're going to discuss intramolecular forces and intermolecular forces. Now what are so I'm going to write it in all capitals, it's easier to distinguish. Intramolecular forces are bonds that hold atoms together. And this could be your ionic or covalent. And because of this, these are strong. They're strong forces. Compare that to intermolecular forces. These are bonds holding molecules together. And because of that, these are weak. Now, a type of intermolecular forces is called the van der Waals forces. And to be even more specific, we will have what we call London forces. So that means when we discuss van der Waals forces, these are forces that are holding molecules together. And they are weak. And a type of van der Waals forces is London forces. Now what are London forces? Now London forces are basically what we use is the idea of what we call a temporary dipole. Now we know a dipole is when there's an unequal sharing of charges, but what is a temporary dipole? Well, in a covalent compound, there's a spread of electrons. And when these electrons move, they can cause one side of the atom to be charged temporarily. And this is what we call London forces. So what this looks like if I draw a picture is, let's say that we have the helium atom. Okay? We know the helium atom has, in this case, 2 electrons. Okay? And this here, we'll draw another helium atom. And again, it has 2 electrons. Now, when these electrons are, in a sense, moving around, if those 2 electrons were now, let's say, for example, now they are here. So they're here now. This would cause this side of the atom to be more negative. And let's say that these 2 also moved here. Again, these 2 will be over here. Now it will cause this side of the helium atom to be a bit more positive, and thus it's going to be attracted to each other temporarily, because these electrons are always moving. So this is a temporary attraction. It's weak. It is not strong. It's not permanent. What we also know is that the more electrons, the stronger the London force. Because as you have more electrons, you could all be forced to one side, and it could cause a bigger positive and negative charge. Again, these are weak though. Just make a note again. These are weak bonds. And not only the weak bonds, they're also temporary. Alright? So, as always, make sure you keep yourself safe and healthy, and I'll see you soon.